Hey physics friends, I'm so sad I can't be in class with all of you guys, but a recording will have to do. So I had module 15 and that was on electric circuits. When a substance is in a conductor, or is a conductor, the charges move freely within it. The charges cannot leave the conductor, but they can just be free to move. And since they are confined to a space they cannot leave, we are able to have control over these charges and utilize the kinetic energy they produce while they are in motion. Here are just 5 examples of a conductor. And that's silver, gold, copper, steel, and seawater. A little bit about what a battery does. A battery holds 2 chemical reactants. One of the chemicals wants to give up its electrons and the other wants to take those electrons. The 2 sides are connected by a conductor where the electrons will flow from one side to the other. And the battery dies when all of the electrons have left the reactant that wants to get rid of them and have gone to the one that wants to take them. When charge travels through a conductor from one side of the battery to another, this is called an electric circuit. And then for electric current, the number of electrons that travel through a circuit can determine how much work an electric circuit can do. The definition of electric current is the amount of charge that travels past a fixed point in an electric circuit each second. And here's an equation for electric current, and that is I equals the change in Q divided by the change in T. And I equals current, and then Q is the total charge traveling past a point in the circuit, and T is the time that it takes for the charge to travel. An electric current will have the units of ampere or amp. That's what you measure them in. Here's a picture of a simple circuit. It's just the battery, the positive side, the negative side, and the flow of electrons. And here is another simple circuit, but this time the battery isn't there. It's just But if I were to cover the positive and the negative signs, you would still be able to know which side is positive, because in a simple circuit drawing, the long side is always a positive side. Franklin thought that the electrons flowed from the positive side to the negative side, and this idea was widely accepted by many scientists. But later on, scientists began to find error in this assumption, and it was discovered that the electrons actually flowed from the negative side to the positive side. But nothing changed. So even though it was found to flow the other direction, it contradicted every drawing that had been made. So people just kept drawing them as flowing from the positive side to the negative side. And this is called conventional current. Current that flows from the positive side of the battery to the negative side. And now to talk about resistance. Every conductor resists flow, and as the book says, each conductor has its own resistance. Resistance is the ability of a material to impede the flow of charge when it is subject to a potential difference. And Ohm's law is what creates the relationship between electric current and the resistance. And this is V equals I times R, and I is the current of the conductor, R is the resistance, so the current times resistance equals the potential difference to which the conductor is exposed, and that's V. Electric power, the higher the power, the more energy output. In the example of an electric heater, the higher the power, the hotter the heater. We have 2 equations for finding power, and these are P equals I times V and P equals I squared times R. And I in both equations are equal current. And then V in this one is the electric potential, and then R is resistance in this one. And both accomplish the same thing. It's just if you don't have resistance, but you have the electric potential, you can use this equation, and then vice versa. Here are switches in a circuit. This is an open circuit, and this is a closed circuit. When a circuit is open, there's no complete connection between the two sides of the battery here, so there's no connection there, and therefore flow is unable to flow. And then in a closed circuit, there is a complete connection, and therefore we're allowing there to be a current flowing through there. And here is a picture of a series circuit, and this is a parallel circuit. In a series circuit, if any of the devices stop working, they will all stop working. So if this one labeled R1, if that one were to stop working, R2 would also stop working because the current can no longer reach R2 because R1 stopped working. But in a parallel circuit, if R1 were to stop working, R2 would still be able to work because the flow does not have to travel through R1. It can just skip right over and go to R2. And effective resistance is basically the sum of all the resistors just equaling 1 effective resistors. So it's as if we could replace them with just 1. So when we add, this is the equation for a series circuit, and it's just adding them, R1 plus R2 plus R3, so on. And that would equal 1 effective resistor. And then for a parallel circuit, you take, well, the answer is 1 divided by R effective, and then equals 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. And that would give you 1 effective resistor for the parallel circuit. A fuse is a conductor that is very thin and it is very heat sensitive. If too much current runs through a fuse, the conductor will break, and this is called blowing a fuse. And then a circuit breaker is made of a material that bends. So if there is too much electrical flow, the material begins to bend. And when it bends too much to a certain point, the switch flips and opens, and the current can no longer flow. And the main difference between these two is you cannot reuse a fuse. If you blow a fuse, you have to buy a new one in order for the circuit to work again. But you can reset circuit breakers. If your fuse keeps breaking or your circuit keeps tripping, this tells you that you are probably overloading your circuit. And don't ignore this, or your house could end up like this. So, anyways, that is all I have for you guys.